Hey everyone, and welcome to our deep dive all about getting prepped for the H13-311 exam.
It's going to be a good one.
Yeah, we've got practice questions, key concepts. We're going to cover things like training models with MindSpore, Python things to watch out for, and neural networks.
Sounds like fun.
Yeah, definitely. And just a fun fact before we get started, did you know that even though TensorFlow is a Google product, it's not just limited to Python?
Really?
Yeah, but more on that later. Let's get started with this deep dive.
So you know what's really interesting about this exam? It's not just testing knowledge. It really shows what's going on in AI right now, like how accessible and scalable everything is becoming and how these powerful concepts can actually be used to solve real-world problems.
Okay, I love that. So before we dive into the neural networks, can we get the basics about the exam down first?
Yeah. Of course, think of this as your quick cheat sheet. The H13-311 is a written exam, 90 minutes long. You have to score at least 600 out of 1,000 to pass.
Okay.
It costs 200 USD to take it, and you can take it in either Chinese or English.
Got it. So it's like prepping your tools before you start a project.
Exactly.
Okay, that makes sense.
Okay.
So let's get to the sun stuff, the practice questions. The first one's about MindSpore's automatic parallel feature. And the name is pretty self-explanatory, but what's the real magic behind it?
So imagine you're building an AI model that's so complex, it can generate photorealistic images from just text prompts. The computing power you would need for that is huge. So automatic parallel comes in, and it's like an orchestra conductor expertly coordinating a bunch of processors, distributing the work efficiently, and you don't have to configure each one manually.
Wow.
So you can create powerful AI models without needing a supercomputer.
That's amazing. It's like composing an entire symphony by hand versus using software to help orchestrate it.
Yeah, exactly.
But even with these amazing tools, sometimes it's the little things that trip us up, right? Question 2 seems to have a little trick for Python users.
Yeah, you're right. It shows a common pitfall when switching between Python versions, like the basic import stays the same. But other things like how Unicode is handled have changed. Like, let's say you have a Python 2 script that uses the exchange function to loop through numbers in Python 3. That's gone replaced by just range.
Oh,
So it's a small difference that could crash your code if you're not careful.
So it's like learning a new dialect of the same language you think you're fluent, but then the slang throws you off.
Pretty much.
Okay, question 3. Now this one takes us into the math world. Don't worry, we're not making you solve equations or anything.
Definitely not. Definitely not. But it is important to understand how different math concepts connect to each other in AI. This question points out that linear algebra is like the foundation of many AI algorithms, but probability is its own thing, not just part of it.
Okay.
Like linear algebra gives us the tools to map out relationships in a network, but probability helps us deal with the uncertainty, like how likely is a specific event in that network. They're both super important, but approach the problem from different angles.
I see. So they're both in the AI toolbox, just different compartments.
exactly.
Speaking of tools, question 4 brings us back to neural networks and gradient descent. How would you explain this to someone new to AI?
Imagine trying to find the lowest point in a valley, but you're blindfolded. You can only feel the slope of the ground. You take little steps downhill, always adjusting your direction based on how steep it feels.
Okay.
That's basically gradient descent in neural networks. We're going down towards the best set of parameters, those knobs you mentioned that make our model as accurate as possible.
So it's like fine-tuning a recipe, making small changes until it tastes perfect.
Yes, exactly.
And just like a chef needs a well-equipped kitchen, data scientists need the right tools. Question 5 tackles a common misconception about Huawei's machine learning service, or MLS. Not just for Python, right?
You got it. Huawei MLS actually supports both Python and R. It recognizes that people have different preferences. It's like having different knives in your kitchen, some for slicing, others for dicing, but all help you cook.
I like that, giving people the freedom to choose their coding language. And speaking of choices, question 6 compares GBDT and random forest. They're both popular ensemble learning methods. What's the key difference here?
This question is about overfitting. When a model gets too focused on the training data and doesn't work well on new data, the statement says that GBDT tends to underfit more than random forest, but that's actually false.
Oh.
GBDT builds trees one after another, trying to correct the previous one's errors, so it's actually more likely to overfit. It's like studying really hard for one exam. You might ace it, but struggle with others. Random forest builds trees independently and randomly, which leads to a wider understanding, like studying the whole subject.
Interesting. So GBDT is like an intense specialist, while random forest is more of a generalist.
Yeah, that's a good way to put it.
And speaking of adapting to different situations, question 7 shows how versatile Huawei Cloud AI is.
What's impressive is how it can handle so many real-world problems, like analyzing crowds for urban planning, using knowledge graphs for policy research, recognizing vehicles for traffic, or detecting intrusions for cybersecurity.
It's like an AI Swiss Army knife.
Exactly.
And speaking of versatile tools, question 8 takes us to LSTM networks, a special type of recurrent neural network.
Yes, LSTMs are great at handling sequences of data like time series or language. Their secret weapon is selectively remembering or forgetting information over time, like a built-in note-taking system that highlights important stuff and discards the rest. They process information over time, focusing on what matters.
So they're like the organized note-takers we all wish we were.
Uh-huh. Yeah, something like that.
And speaking of processing information efficiently, question 9 is about TensorFlow and how it builds models. It points out that you don't have to manually update tensor weights.
This is where TensorFlow shines. Instead of making developers update weights manually, it uses algorithms like Atom or SGD to do it automatically. Like a self-driving car for model training, you set the destination and TensorFlow figures out the route.
So TensorFlow takes the wheel so we can enjoy the ride.
Exactly.
And speaking of taking a step back, question 10 reminds us that TensorFlow came from Google, a company known for innovation and open source.
Right. TensorFlow is born out of Google's Brain team. It shows Google's dedication to pushing AI forward and making it accessible. It also connects to Huawei, making MLS support both Python and R. It points to a trend of inclusivity in AI. Innovation thrives when different voices and approaches are welcomed.
It's like building a huge research lab where everyone can contribute no matter what tools or languages they prefer. And remember, this isn't the end. Keep learning, keep asking questions, and keep pushing those boundaries.
Most importantly, never stop asking why the best insights often come from the simplest questions.
So until next time, keep exploring the amazing world of AI.